Okay, geometry lesson 4.4. We are continuing to prove that triangles are congruent, but now we're going to use two other ways, angle, side, angle, and angle, angle, side. Okay? So, up until now, to prove you had two congruent triangles, you had to either use the definition, which was 3 congruent angle pairs and 3 congruent side pairs, corresponding parts, okay? Or we could have used side, side, okay? 3 sides in one, congruent to 3 sides in the other. Or you could have used side, angle, side. 2 sides and the included angle. So side, angle, side. All right, were the 3 ways we had to show we have congruent triangles. In 4.4, we have 2 more ways. So postulate 21 is angle, side, angle. And we use ASA for that abbreviation, okay? And what it tells us is that if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of a second triangle, then your triangles are congruent. All right, so you have one triangle here. We're going to call this triangle A, B, C. Second triangle here, call this triangle D, E, F. And it says 2 angles. So angle A is congruent to D. Angle C is congruent to F. Actually, let me write it down here. Okay, that's your 2 angles. So 1 angle, 2 angles. And the included side. So if these are the angles, this is the included side. So AC congruent to DF. Then our triangles are congruent. So ABC congruent to triangle DEF. 2 angles, the included side. 2 angles, the included side. Not any side, it's the side that's in between the 2 angles for angle, side, angle. Okay? Then we have theorem 4.5, which is angle, angle, side. We're going to call that AAS. Angle, angle, side. Okay, so it says if 2 angles and a non-included side. Of 1 are congruent to 2 angles and non-included side of a second triangle. Then your triangles are congruent. Okay, so basically between these two theorems, if you have two angles and a side, you can show your triangles are congruent. It's just a matter of where that side is, which reason you use. If it's in between the two angles, you use angle, side, angle. If it's not, you use angle, angle, side. Okay, so again, here's my two triangles. Here's triangle A, B, C, and triangle D, E, F. Okay, this says two angles. So angle A is congruent to angle D. Angle C is congruent to angle F. There's my two angles. And a non-included side. So any other side but the one in between. So let's say BC is congruent to EF. Then your triangles are congruent. So triangle ABC is congruent to triangle DEF. Again, remembering to label them in the correct order. Okay, so those are our last two ways to show we have congruent triangles. So if I give you C, G, D, E, F, and I mark it 2 marks on angle C, 1 on G, 1 on E, and 2 on F. We want to decide if there's enough to show these triangles are congruent. So first, we know nothing about the sides. Okay, so unfortunately that stops us right there because all the ways the definition involves sides, side, 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 angle, side, angle, side, angle, 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 side. Every single way we have to show congruent triangles involves knowing at least one side. So no sides are known, so therefore not enough info is known. We can't show it. Okay, if I'm given this is H, I, J, K. 1 mark here, 2 on this. 1 mark here, 2 on this. Is there enough to show I have congruent triangles? Okay, so again, I have 2 angles. Right, so this angle H and this angle J, then this angle H and this angle J. So we have 2 angles. Do we know anything about the sides? We don't know about these two, but using the reflexive property, HJ is congruent to itself. So that would be angle, side, angle. You have enough information to show it. All right. Then we have one proof, and that's lesson 4.4. So given angle B is congruent to angle C, angle D is congruent to angle F, and M is the midpoint of DF. We're going to prove triangle BDM is congruent to triangle CFM. Pretend these are straight lines. So here is D, here is B, and M, F, and C. Okay, with what we're given that B is congruent to C. So here is B and C. Angle D is congruent to F. Here's D, here's F. Okay? Based off of the next fact, right? M is the midpoint of DF. So midpoint, what does it do? Divides your segment into two congruent, that's key, parts. Okay, so if M is the midpoint of DF, that tells us that DM is congruent to FM. So angle, angle, side. And we've got our proof. Okay, and we just have to write it out. Okay, so start with what is given to you. Angle B is congruent to angle C. Angle D is congruent to angle F. Okay, those we're just going to leave by themselves. Our second given statement, or our second step, we're going to use our second given statement that M is the midpoint of DF. We're doing this separate because we need to do something with that statement. These two, that's enough. That gives us our angles. This we have to do something with to add to our proof. Okay, so since M is the midpoint, we can say that DM is congruent to FM by the definition of midpoint. And then you've got your proof, right? So lastly, BDM is congruent to CFM by angle, angle, side. And you have your proof. So that is 4.4.